Okay, hello everyone. This is my Physics 2212 Lab 4, which is about bar magnets. So here's an introduction. So the purpose of this lab is to observe and measure the distance dependence of the magnetic field due to a small bar magnet and compare those measurements to the distance dependence predicted by the equations on and off magnetic fields derived from the Bose-Schwarz law. Me and my group got the following results. So we got N is equal to negative 3.3, and we got mu is equal to 1.5. So here are some fundamental physics principles. So we did use the Bose law, which describes the magnetic generated by a constant electric current and in the magnetic field of a dipole, and then the distance dependence formula of a bar. So we did use those in this lab. So our observed model, so our initial conditions, which is the bar magnet in the magnetometer app on the phone. And we got our system to be the bar magnet, and then the surroundings to be everything else. And then this is just a picture of me and my group performing the experiment. So here we got our data and collections on Excel. So we got our line to be y equals negative 3.3231x minus 15.034, and then the rest of the data are shown here on the right. So this is my calculations. So I got k is equal to 2.954 e to the negative 7, and I got mu to be 1.477. All right, so here is some more data. And so we got our averages up top, the off-axis field. Then moving on, so we made a couple of observations. So when the magnetometer was far away from the magnet, it measured a near zero magnetic field in the x direction. And then as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. So this is my VPython. So I got mu mag to be 1.477. And this is just the rest of my code. And then I got the results here, which shows the magnetic field. And then here are some similarities and differences between models. So the experimental model off-axis field is 6.38 e to the negative 5, and then the computational model off-axis field is 1.76 e to the negative 5. And then some assumptions are bar magnet acts as a magnetic dipole to apply Bose-Schwarz law, and negligible external forces in the computational model. And then I want to go over some possible sources of errors. So the electronic and magnetic devices in surroundings could have affected readings. So that could be, for example, like computers and phones nearby. That could have affected readings. And then we got the location of the magnetometer was not precisely found. And then so here's the discussion. So what if you hadn't oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your seeds have changed? So the Earth's magnetic field would interfere with the bar's magnetic field, making the results less accurate. And then what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? And so magnitude of the magnetic field would have doubled but remain in the same direction. And then that is it for my lab. Thank you for listening.